When a new supercar hits the market, the public usually asks one immediate question: what's the top speed? It's the easiest number to print on a poster, and for decades, it's been the default yardstick we use to measure automotive greatness. By that standard, the McLaren 720S was an absolute triumph. With its lightweight carbon fiber tub and twin-turbo V8, it set the benchmark for modern supercars, easily breaking the 210-mile-per-hour barrier. Then, McLaren engineers decided to turn the dial even further. They built this, the 765LT. They gave it 755 horsepower, swapped in components from their hypercar division, and stripped the vehicle down to an astonishing 2,952 pounds. The LT badge stands for Longtail, a lineage that traces directly back to the iconic F1 GTR race cars of the 1990s. That badge is a strict promise. This vehicle is built explicitly for track dominance. But there is a glaring contradiction on the spec sheet. Despite having more power and significantly less weight than the 720S, the 765LT is exactly 6 miles per hour slower in a straight line. On a closed circuit, outright terminal velocity rarely wins races. To build a faster track car, McLaren engineers intentionally threw away top speed, executing a highly calculated trade-off to capture something far more valuable: cornering speed. To understand this, we have to look at the air moving around the car. At the front, the nose was extended by almost 2 inches, and the entire carbon fiber splitter was lowered closer to the pavement to aggressively scoop oncoming air. At the rear, they stretched the bodywork and mounted the active rear wing higher and further back, giving the car the elongated profile it's named for. These aerodynamic tweaks alter the airflow, creating 25% more downforce that violently pins the tires to the tarmac. But this grip exacts a heavy toll. The downward pressure acts as a parachute, creating a dense wall of drag that chokes high-speed acceleration. The engineers accepted this penalty. They willingly capped the car's top-end highway speed because the immense grip allows a driver to carry significantly higher speeds through the apex of a corner. Raw horsepower alone cannot punch through that much air resistance. To move forward, McLaren had to completely re-engineer power delivery to the rear wheels. They opened up the 7-speed transmission and swapped out the standard final drive gear for one forged from 20 NICH. That is a highly durable nickel-chrome alloy, typically reserved for Formula One race cars. This graph compares their acceleration curves. While the older model climbs smoothly, the 765LT's new gearing creates a sharp, aggressive spike, delivering 15% quicker in-gear acceleration. McLaren specifically tuned this ratio for the violent acceleration zones found immediately after a sharp turn. Specialized mechanical gearing acts as the critical bridge. It overcomes the aerodynamic drag, ensuring that the car delivers instantaneous, usable power exactly when a track driver needs it most. Downforce and aggressive gearing are only effective if the car isn't too heavy to move. To maximize this new setup, the engineering team was given a mandate to strip 176 pounds off the vehicle. They scrutinized the greenhouse, throwing out standard automotive glass. In its place, they installed thinner windshields and lightweight motorsport-style polycarbonate for the rear screens. They fabricated a quad-pipe exhaust system entirely out of titanium. That single switch alone dropped over 8 pounds from the rear of the vehicle. They targeted the wheels next, swapping the standard rims for ultra-lightweight forged alloys. This eliminated nearly 50 pounds of unsprung mass, massively improving the suspension's ability to react to imperfections in the road. The weight loss program reached microscopic extremes inside the cabin. The carbon composite center tunnel was engineered down to a thickness of exactly 0.8 millimeters. To handle this aggressive chassis tuning, the engineers integrated components directly from their hypercar division, namely triple-layer head gaskets and carbon ceramic brakes from the McLaren Senna. This obsessive pursuit of lightness guarantees that every single ounce of horsepower is spent propelling the car forward, completely neutralizing the sluggishness that usually comes with heavy aerodynamic drag. When you integrate the aggressive downforce, the shortened gearing, and the extreme weight reduction, the real-world result is staggering. The car explodes from 0 to 60 miles per hour in just 2.4 seconds. This power-to-weight ratio fosters a near telepathic connection between the driver's hands and the car's behavior on the tarmac. This is why a standard drag race or an open runway top speed run completely fails to measure a machine built for this purpose. A track car is designed to brake late, turn sharply, and accelerate out of apexes, not just drive in a straight line forever. McLaren abandoned the pursuit of a highly marketable top speed, recognizing that chasing a single, superficial number compromises the overall dynamic balance of the vehicle. True track dominance is a calculated alchemy. It requires giving up the vanity of top speed, embracing the aggressive bite of drag, violent mechanical gearing, and an absolute obsession with lightness.